Good afternoon, everyone. Yes, good afternoon, everyone. Am I audible to you? Yes, write your response into the chat box. Voice is clear, everyone. Okay, and screen is visible properly, Kinjal? Kunal, now voice is clear. Kinjal, okay. Okay, Roshan, okay. Please wait for the 1 minute. Yes, we discussed in the previous lecture session and one lab session the Laplace transform basic formulas, definition formula, as well as first shifting theorem of the Laplace transform, right? Laplace transform main application, as we discussed earlier, Laplace transform converts the differential equations in the time domain to the algebraic equations in the frequency domain. And the three important steps for converting the given differential equation into the algebraic equation. Okay. Now this is the application, right? Laplace transform is applicable for this kind of the functions: continuous function, piecewise continuous function, periodic function, step function, as well as the impulse function. Okay, this is the definition formula of the Laplace transform. Laplace of f of t is equal to integration 0 to infinite e raised to minus st f of t dt, right? And is equal to, when we apply this integral, that's why we are getting f of s. Now some basic formulas we discussed into the previous lecture session, as well as the first shifting theorem also we discussed onto the previous session. Okay. Now today we discuss the problems based on the first shifting theorem. First, we write over here the first shifting theorem. If Laplace of f of t equal to f of s, then Laplace of f of t e raised to minus at. 1 minute. Yes, is f of t is multiplied with the e raised to at or e raised to minus at. 1 minute. Yes. E raised to at into f of t is equal to f of s minus a. We discuss is s is shifted by s minus a. And Laplace of e raised to minus at into f of t equal to f of s plus a. Right? This is the first shifting theorem. For example, when we apply onto the particular formula, suppose our first formula constant, and Laplace of e raised to at, 1 minute, Laplace of e raised to at, wait, some problem in this pen tablet, wait for the minute, into k. Yes, therefore we know that the k formula, when Laplace of the any constant, then k by s. Therefore here k by s minus a. Okay. Now other formula, Laplace of t power n, right? When n is a integer. Yes, n is an integer. Yes, Rahul, wait for the minute. Integer. Therefore, we know that n factorial upon s raised to n plus 1. Write this formula. Now this is multiply with the e raised to 8. Everyone please join in time. E power n, therefore n factorial s minus a raised to n plus 1. Right? Only the change in place of s. Any doubts in this first shifting theorem? Then quickly raise your hand. If you have any doubt in the first shifting theorem, then quickly raise your hand, everyone. Anyone having any doubt in the first shifting theorem? Okay. Now the next example. Find Laplace of e raised to 2t into sine 2t cos 2t. Okay. Now first we solve this term, and then after we multiply with the e raised to 2t, right? We apply e raised to 2t at last. Laplace of sine 2t into cos 2t. Now we know that this is the trigo function. That's why we can't solve directly. Therefore, what to do? Unmute yourself, or you can write into the chat box. How can we solve this product of the trigo function? How can we convert into the addition or the subtraction form? Yes, anyone write your answer into the chat box, or you can unmute yourself. Okay. Yes, Kinjal, Priyanka, Karl, Kunal. Yes, one answer into the chat box. Very good. Amit. Yes. No problem. Yes, Karnavi. Good. Right? 1 minute. Divide by 2 and multiply by 2. 2 sine 2t cos 2t. And here the angle is the similar. Therefore, we can convert into the double angle directly. Therefore, this is the sine 4t. Right? 2 sine theta cos theta is equal to sine 2 theta. Okay, we know that. Now, first we apply the Laplace transform. Sine function, that for constant term into the numerator 4, divide by s square plus 4 square means 16. Okay, and this is 2 and 2 cancel out. Therefore, the 2 upon s square plus 16. This is the answer of sine 2t cos 2t. Now, when we multiply onto the left hand side by e raised to 2t into sine 2t cos 2t. This is the applied mathematics, right? Therefore, when we apply onto the left hand side, that's according to the change onto the right hand side. Okay, therefore here S is shift by. Here what is the coefficient of T? 2. Now tell me, in place of S, we have to shift which term? In place of S, we have to shift which term? S की जगह पे हमें क्या शिफ्ट करना होगा? Yes, but S is remains as it is, therefore S minus 2. Yes, can check S minus 2. Therefore 2 upon S minus 2 whole square plus 16. This is the final answer. Okay. Here no need to expand the denominator, because if we expand the denominator, nothing will be cancelled out. Therefore no change. Right. This is as it is. Everyone please note it down this question quickly. If done, then write yes into the chat box. Complete this slide, then quickly write yes into the chat box. Okay, Amit. Okay. Now the next question. Now very easy question. You can do it yourself. 1 minute. Yes. Second example. Find Laplace transform of e raised to minus at cos pt. 1 minute. Wait for 2 minutes. Yes, find the Laplace transform of e raised to minus at e raised to minus at cos bt. Okay. Yes, I already admit to you 2 times. Okay, now everyone do it yourself. What is the first step? First find Laplace of cos bt and then apply the first shifting theorem. Quickly, very simple question. Yes, if you get it the answer, then raise your hand quickly. If you get it this answer, then quickly raise your hand. Yes. Here the power is the minus, Amit. Your effort is very good, but power is the minus, right? First, Laplace of cos bt. Yes, Laplace of cos bt. This is s upon s square plus b square. Now, by first shifting theorem, Laplace of e raised to minus at cos bt. Here minus power, therefore s is shifted by s plus a. Therefore s plus a, divided by s plus a square plus b square. This is the answer. Clear, everyone? And two more answers into the chat box. Yes, Roshan and Kinchal, Karnavi. Very good. Okay, Amit, clear your mistake. Right, in place of s minus a, s plus a. Okay. Okay. Now one more question. Now everyone try yourself. It's not very tough. Find LT of e raised to minus 2t sine 4t plus t square. Everyone do it quickly. First apply this bracket Laplace transform each and every term, and then after using the first shifting, right, multiply with e raised to minus 2t. Yes, try it, everyone. First, Laplace of sine 4t t square. Therefore, Laplace of sine 4t plus Laplace of t square. What is the sine 4t? 4 by s square plus 16. And t square is 2 factorial, and this is 2 by s cube. Okay. Now by first shifting, s is shifted by s plus 2. Now, 1 minute. Yes, yes, very good. Kunal, one term is remaining. Yes, one term is correct. Yes, kin children. Yes. But in place of s, change this term. Right? Apply the first shifting theorem. Now, by first shifting theorem. S is shifted by s plus 2. Therefore, Laplace of e raised to minus 2t sine 4t, when this function sine 4t plus t square is multiplied by e raised to minus 2t. Therefore, onto the right hand side, the change is only each and every term of s plus 2 square plus 16 plus 2 factorial s plus 2 whole cube. This is our answer. Yes, 4 to 5 answer into the chat box. Very good. Sushil Kumar, then Nitish, Roshan. Yes, very good. Okay, now you understand better the first shifting theorem. Now, one change in this, right? One new example, trigo multiplication and all this we done into the previous, but here you do it yourself one question and we will start the new question into the next one. E raised to 3t cos square t, and I think this is third one, this is fourth and fifth. Laplace of e raised to minus 2t cos 3t sine t. Right? This two question using the trick of formula, you can do it yourself. Do it, everyone. Right? You can do it yourself. Mihir Avalia. Join in time, everyone. Because in the lecture session, I am focused on to the lecture session and all this, and on to the chat box. Everything is not possible, and please join in time. And if network issue sometime, then it's okay, but not in the all the session in out is on point. That's not good habit. Ignore the phone calls during the lecture session, right? And find the okay, no problem. And Kevin, you write also the answer into the chat box. Yes, mute your mic, everyone. I think Mihir mic is on. Rahul Kumar Gupta. Yes, now the one new thing into the first sitting. Okay, very important thing. Next question, example number 7. Yes, find LT of e raised to minus 4t sine ht sine t. Now this is the new thing. Okay, but we know that when we derive the hyperbolic functions, right, we know that very well. Sine hyperbolic we can convert into the exponential term. We know that sine ht or sine h theta e raised to t minus e raised to minus t divided by 2. Okay, this is the formula. If cos ht, then here the middle sign is the plus. Other all the terms remain as it is. Okay, now our function is e raised to minus 4t sine ht into sine t. Okay, now first we write e raised to minus 4t. Now we put it this value of the sine ht, e raised to e raised to minus t divided by 2, and sine t remains as it is. No change. Okay. Now 1 by 2 taken common. Now e raised to minus 4t and e raised to t. Therefore e raised to minus 3t minus e raised to minus 5t sine t. Okay. Now you can also write like that 1 by 2 e raised to minus 3t. Here two questions. Sine 3 sine t minus e raised to minus 5t sine t. Right? This is the simplification of the given function right now. Okay, this is question number, but two question into the homework, that's why no problem. This is question number 6 or 7. It's no issue. Now, what is the Laplace transform of the sine t? Okay. Now we know that now Laplace of sine t is equal to 1 upon s square plus 1 as per our first table of the Laplace transform formula. Okay. Now, by first shifting theorem, we can also write like that. First shifting theorem, right? We are writing over onto the left hand side the given question. E raised to minus 4t sine ht sine t. Right? This is given question. And now the simplified version finding with us. 1 by 2 Laplace of e raised to minus 3t sine t minus 1 by 2 Laplace of e raised to minus 5t sine t. Okay. Now here s is shifted by s plus 3, and here the s is shifted by s plus 5. Okay. Therefore 1 by 2 in this one, equation number 1. Now s is changed. No change into the numerator. 1 upon s plus 3 in place of s whole square as it is plus 1 as it is minus 1 by 2 again numerator as it is in place of s plus 5 square plus 1. This is the final answer. This is the final answer. If you want to give the more simplification, then you can do it yourself, but here no change. When you simplify more, right, you can open this, take the LCM, open the polynomial into the denominator. You can do it like that. But here, no change. Therefore, this is the final answer. Everyone clear? Okay. Now, you can do it, this kind of the question for the cos function yourself. Laplace of e raised to 3t cos, 1 minute, cos ht cos t. Yes, cos ht into cos t. Do it yourself, everyone. First, convert this. The hint is what to apply. You have to cos ht equals e raised to t plus e raised to minus t by 2. Everyone do it quickly. I'm waiting for your answer into the chat box. Yes, I'm waiting for your answer, everyone. You can generate so many questions yourself for the practice. Right here, cos ht cos t. For practice, you can apply cos h2t cos t, cos h2t cos 2t. Right? In place of e raised to 3t, you can change it e raised to t, e raised to 2t, e raised to minus 2t. That's why so many questions from one question we can generate it for the practice, and the concept is fixed in your mind. Okay, everyone? Yes. Okay, tell me what is the simplified version? What is the 2 exponential power? You will get it. Write into the chat box. 2 exponential power after you put in the value of the cos ht. Yes. Our question is uh, first we no need to write e raised to 3t, I think so. Yes. E raised to 3t cos ht cos t. First we simplify this. E raised to 3t cos ht means e raised to t plus e raised to minus t divided by 2, and cos t as it is. Yes, one answer is here. Yes, Kinjal, very good. Right, now again one more answer. 1 minute. Yes, yes, Samnit, very good. What about the other students? Now your first sem remaining exam is already scheduled, right? You enroll in this sem 2, and you can get it the better result in sem 2 also, right? E raised to 4t plus e raised to 2t. And this is the online teaching. That means self-discipline. You can Do it yourself everything. Yes, Mihir, very good. E raised to 4t cos t plus e raised to 2t cos t. Okay, now first we find it Laplace of cos t, right? When this concept is applied over here, when the one function is the trigo function and one function is the hyperbolic function. Students, when we write it in your notebook or when we do the practice of this all the questions, then please by forget the given function is in which format, right? Accordingly we have to apply like that. जो आपको फंक्शन दिया है वो किस फॉर्मेट में है उसके अकॉर्डिंगली आपको अप्लाई करना है, ठीक है? तो बाय फॉरगेट करना सीखिए क्वेश्चन को। ओके, क्वेश्चन समझ में आ गया तो उसके स्टेप्स भी माइंड में आ जाएंगे और फिर आप इजीली अप्लाई भी कर सकोगे। एस अपॉन एस स्क्वायर प्लस, ओके। नाउ यस Kanavi, very good. Now by first shifting theorem, Laplace of, I'm writing over here the given question, e raised to 3t cos at t cos t is equal to 1 by 2 Laplace of e raised to 4t cos t plus 1 by 2 plus 1 by 2, wait for the minute, yes, Laplace of e raised to 2t cos t. Yes, and the answer, you know that very well, right? Yes, everyone. The final answer is 1 by 2. Here, no space. You can note it down yourself, right? And regarding some power issues today, that's why Wi-Fi is in and out. 1 by 2 Laplace of e raised to 4t cos t. Therefore, s minus 4 whole square plus 1. And in the another part, s minus 2 whole square plus 1. Okay, clear everyone? Okay. Now the next question. Yes. Now, after the first shifting theorem, I think so. Now, no doubt into the first shifting theorem, everyone. Now we learn one more property, multiplication by t. Okay. First, we learned the basic formulas of the Laplace transform. Now we operate this basic formula one by one. First we did this basic formula is multiply with e raised to at or e raised to minus at. Therefore, s is shifted by s minus a or s plus a. Right? Now we learned one more property. This is differentiation of the Laplace transform or multiplication by t. Differentiation of LP or multiplication by t. Now the basic function of the first table is multiply by the t. Then what is the change onto the right hand side? Right? If Laplace of ft equal to f of s, then Laplace of t power n ft is equal to minus 1 raised to n nth differentiation with respect to s of f of s of f of s. Okay, now this formula, when we write for n equal to 1, then Laplace of tft, right? Therefore minus 1 power 1, therefore minus t by ds, n is also 1, of f of s, right? What is the meaning of this property? When the basic function is multiplied with the t, then we have to apply the differentiation of the answer, right, with respect to s, and here the minus sign. Okay, if the t square, then apply 1 by 1. First find Laplace of tft and then find Laplace of t square. Okay, clear everyone? Okay, now we understand the one problem. Laplace of,
Hello, ma'am.
yes,
Ma'am, previous slide, please.
okay, 1 minute. Note it down this quickly. If done, then write yes into the chat box. Yes, done. This slide, then
Done,
write
ma'am.
yes, done.
Yes, ma'am.
Okay. Okay, now we do it one problem of the multiplication by t, right? Laplace of t sine omega t. Omega is a constant. Okay. Now as per our rule, first apply the Laplace transform of sine omega t and then apply the whole term. Okay, these are the two steps. Now we find the solution. Laplace of sine omega t. Therefore, write the constant omega upon s square plus omega square. Right, this first step is over. Now we multiply by t. Now left side we multiply with the t. T sine omega t. Okay. Now as per rule, when the t multiply with the function, right, then here minus sign, then t by ts of the answer. Answer means Laplace of sine omega t, answer is here. This is applicable here. Omega upon s square plus omega square. Clear everyone? First find the basic function Laplace transform, then multiply with the t. Therefore onto the right hand side, as per the rule, the minus sign, d by ds, differentiation of the omega upon s square plus omega square. Clear everyone? Now tell me, how can we find it, this differentiation? Using which rule? Using u by v rule, right? Division rule of the differentiation, right? This minus sign is as it is into the bracket, v as it is, derivative of the omega, right? This is the first question, therefore I am writing over here d by ds of omega minus omega as it is, d by ds of s square plus omega square, right? You know this rule for the differentiation, and into the denominator this term square. Now tell me, what is the differentiation of the constant one? कांस्टेंट का डेरिवेटिव क्या हो जाता है? कांस्टेंट का डिफरेंशिएशन क्या होता है? बताओ फटाफट.
0, ma'am.
Yes, very good. Constant differentiation is the 0. Therefore here 0 minus omega as it is, s square plus omega square, s square differentiation is 2s, omega square differentiation is the 0. Right, this is the first question, that's why we specify everything. Otherwise you can directly write it over here, the derivative of the omega, derivative of this term, and then the simplify, right? S square plus omega square whole square, right? And therefore the answer into the next slide, first you note it down, this is minus minus plus 2s omega. I'm writing over here this answer. The answer is 2s omega upon s square plus omega square square. Okay. Now quickly है तो power in out